Did you say day 4?
Yes.
And it's, guys, is anyone seeing it?
It's over here.
I found it, but I had to refresh my browser.
Ah, okay.
So I just opened the component scene, and we're going to import into our 3D models. So 3D models, we're going to import this assembly composition. Is the one that I have uploaded in Drive. So I'm bringing it in. And over here, again, I'm just going to disable all of these. I don't care about those. Generate colliders and click apply. I'm going to bring it in my scene. Usual situation. I'm going to unpack the prefab. I'm only going to take this one, which is the one that I want, and delete everything else. As you can see, it is rotated -90. I don't want that. And if I double click, it's going to focus. And this is our assembly. You see our component in the side is huge. Remember, we have scaled it by 100. That is why. But anyway, I'm just going to delete that because we don't need it anymore. Components, delete. Component manager, also delete. And while we're deleting, we're going to save this scene as a new scene. So I'm going to file, save as, not save, because you're going to lose the scene. Save as, I'm going to go to scenes, and I'm going to name this design 1 assembly sequence. Okay, so now it's a new scene. Let's delete that. Okay, so now we have our assembly basically. And if you see, this one has all of the different components as children. That's how I exported it from Rhino. In your case, you have to bake your meshes, you have to bake them in the correct order. And then if you export them all together, if you bake and export them, they will be in the correct order over here. So you can see how this is. Obviously mine doesn't have any order at the moment. It doesn't make sense necessarily, but I'm sure yours will. So we're going to write a script today. We're going to name it assembly manager, and we're going to place it on the parent object. You see, the parent object is nothing. It doesn't have any mesh. It's just the container that contains all of my components, and it's the parent. Let's go create our script. So I'm going over here in scripts. I'm going to right click, create, choose our script. I'm going to name it assembly manager. Double click to edit it. And we're going to start. So what this script is going to do today, it's going to, we're going to use a slider UI element, and we're going to use it to gradually turn on the game objects of the assembly sequence, so the components. And we're also going to display some information about the assembly. We're going to display the overall weight, the overall component count, and then we're also going to display some live information, which will be how many components have currently been assembled and what is the current weight of our assembly. So to do that, first of all, we're going to be using 2 additional libraries. One is the UI library. So we're using Unity engine. .ui and using TM Pro, which is the Text Mesh Pro, the high quality kind of text elements that we discussed yesterday. And then we're going to create some public variables, so some things that we're going to be able to affect from the inspector outside for our script. And first of all, we're going to create a public gradient. We're going to name this assembly color, sequence color. With this one, we're going to be coloring as we move the slider. We're going to be coloring our components so that visually in the app we can understand which one was placed last, which ones were placed first, and which ones were placed last. And this coloring will be dynamic. So the more elements we place, the more this range of color will adjust. So we're going to use this gradient for that. And then we're going to need a public float, which is going to be the component weight. And we want a public float, which is going to be the sequence step. This will help us control how fast our animation will be playing. We're going to use the slider to animate the sequence, but we're also going to use a button. So when you click the button, it will play the whole sequence, and this will define how fast this sequence will be playing. And then a little trick to have a tidy inspector, you can define headers and spaces in the variables that you expose. So to define a header, we open these square brackets, open and close, and we write inside header, open and close parentheses, open and close quotation marks, and over here I'm going to write UI, come on, UI elements. And it's red because I don't have anything underneath it. And now we're going to type public slider. And we need some fields to the ones that I say we're going to display information, which are basically going to be some text fields that we're going to update their content through this script. So we want a public TM Pro text, TMP text. And let's name this count text. We want a public, again, TMP text. Let's name this weight text. And a public TMP, text. We want this to be the D count text. That means the dynamic count. And the public TMP text. This is going to be the D weight text, dynamic weight. So these are all references to UI elements. And let's save this and see how this looks outside in Unity. So over here, like I said, we're going to place these components over on the parent object of all the components of the assembly. So we're going to add components and assembly manager. You see how the header element appeared. So if you want now to create some sort of fields that have a different kind of content, we can use another header and they will be separated like that. So it's a way of having this look a bit tidy. So for the sequence color, let's create a gradient. We've created one before, or haven't we? Yes, we did for the line renderer or the trail renderer. If you don't remember, you click on the color on the bottom, come over here, adjust the color that you want. Same for the other one. If you want to add a new color, you click on the line and just under the line, and then you adjust it. Come on, you adjust it in the same way. And if you want to take a color out, you just pull this little arrow down. I'm going to use well, I'm going to use one from yellow, but I wanted to go back up to red actually. And I'm going to take this so close. So basically I want my components to be mostly yellow. Just the last ones, I want to make them red. So this is how I will achieve that.
In the inspector window, I don't have the assembly manager script. I'm not sure how to add it.
So you go over here in the game object and you click add component and you look for it. You type assembly manager and it should pop up. Is it?
Okay, that's it. Add component. Under scripts, I don't see.
Yeah, there's an error. So if there's an error, I think you can't see it because even for me,
Yes,
the
if
same
there's an
issue.
error. If there is
Could
an
you
error in your
share the
code.
script?
It
Is
says
there an
no
error?
issue. It says no issues found.
Sorry? No issues found.
Yeah.
Okay. So over here in the console, does it print anything when you save the Visual Studio file?
My character controller.camera hides inherited member component.camera. It's a yellow color text.
This one doesn't matter. It's these ones that we care for. The red ones.
Yeah, I don't see any red ones.
Okay. Can I see your screen for a minute?
Yeah, sure.
Okay. Why do you have the, regardless of that, this named, let me annotate. This one shouldn't be inside this one. We don't care about that one. So if you can collapse it.
Just move everything out.
No, don't. Yeah, you can just click on the drop down. Not like that. Click this one.
Yeah.
No, don't delete it.
No, I'm looking for the collapse.
Oh, you can just click on the arrow, this one over here.
Oh, right. Okay.
And,
I thought you meant. Okay.
And just take it out. Just drag it and drop it. Yeah. And delete that other one. And now you're named. Is it on 0? Yeah. So turn this to 0. Okay. So now this is correct. And if you add component, what happens? Start looking for assembly. No, just type over here. Okay. Interesting. Can you drag this and drop it over here? You see when it turned blue? Yeah, drop it when it turns blue. Can't that script because script class cannot be found. Have you created? Oh yeah, no gaps. It's a class name. So
that's fine. Okay.
Yeah, every script is a class, so we don't add any gaps. So change the gap there and also go inside the script and change it over here. Yeah, it's probably backing out a bit. Maybe open it again. So change the name. Okay, now if you save, it should work. Yeah.
Yeah, that's done. Okay, thanks.
No problem. Okay. Where are we? Oh yes, I just assigned the sequence color, component weight. I don't know, give me a relatively realistic component weight, guys. No guesses?
The groups that did the prototype, guys. George, first group, second group.
Yeah.
What's the weight?
2 kilograms.
2 kilograms. These babies are heavy.
No, like a max of 2.5.
Okay, so let's take it 2.5. Sequence step, I'm going to take it to 0.1. And we haven't created these components yet. So let's do that. We're coming over here in our canvas. Remember, it's the same one that we had. Oh, also, the camera was adjusted. As you can see in the game view, it was adjusted for a larger element. So let's just move it so that it looks at our current one. I'm gonna turn everything to 0 just to take it close to the object and then start moving it again. So rotate a little bit. You can also use these planes to move them in the different planes. Maybe rotate a little bit more. Okay. And I'm also going to disable this orbit camera script because it's going to make our life difficult for today. So let's just have it off. Okay. So we want to go in our canvas and we want, remember we had this canvas, it was this overall thing which overlays on our camera. And we had then this panel, which is this small thing. And inside here we had the home button, the info button, play, the shop, and we have over here this info panel, which had some information about what was going on with the component. So let's first create the slider. So let's create it inside the canvas, just as a different element. And we go right click on the canvas, we go to UI, and we do slider. And it will give us this lovely component. The first thing that we want to do is let's adjust the width. So let's make it enough. We're going to place it over here in the bottom. So let's make it long enough, wide enough that it fits nicely here. So I'm going to make it maybe 200. No. 800, maybe a little more. 1,100. Yeah, that looks about right. So we can either place it by hand or we can use the anchoring system. I'm going to use the system, so I'm going to place it on the bottom, center bottom of my canvas by holding Shift and Alt. Click there. You see where it placed it. I'm going to move it up by 80, no, 40, 45. So it will come to the middle of those. And then I'm just, well, by hand, just move it a little bit so it's a bit centered. So here's our slider. How does, you see that, like all the UI elements, it has a rect transform and it has the slider component. And over here in the slider, we have some capabilities. So we have, if we wanted to go from left to right, we can change it from right to left, bottom to top, top to bottom, depending on the element. We can define a minimum value and a maximum value. So basically what the slider does is it changes a number. So when I am in my game, if I move it, you see how it's replicating the slider over here in the inspector, and it's basically changing a number, and it's taking it from 0 to 1. I can also make it take whole numbers, so now it will not show any floating points. What happened? Well, maybe it didn't like it while it was playing. Oh yeah, so it's a very small range. It only goes from 0 to 1, so it can only snap here or snap here because it has a very small range. So we can adjust the range to whatever number, from whatever number to whatever number we want. And like the other interactive UI components, over here we have this on value change, which means that it will fire an event when we're dragging the slider. And if we open this component over here, game object over here, we see that it has a lot of things going on. So first it has a background, which is, let me make sure that I remember them correctly. Yes, so the background is basically the color that this one displays when it is unfilled. So this is the background. Oh, damn it, not whole numbers. This is the background, and this is the fill area, basically. So if we want to change the color of the background, we will change the color of this image. Then we have the fill area, which basically just has a parent container, and this is the fill. It's a different image, and this is, like I told you, the fill. And then we have the handle, which is this little circle here, and we can change its color from here. So I'm just gonna use these pinky colors that I was using for the rest of the elements. Really quickly, I'm gonna grab the color, Control C. I'm gonna leave the background to white, but I'm going to change the fill to this pinky one. And same for the handle. Maybe take the opacity down a little bit. And I'm gonna play it and see how it looks. Oh, so I changed it from whole numbers while it was playing. This one, not whole numbers. Let's see. Okay, so this is our slider. Background color, field color. I'm okay with that. So we have customized the slider. Let's go ahead and bring it over here. So this is the slider, the parent object. We're dragging it and dropping it over here where it says slider. And over here, we're going to adjust basically what's inside this info panel. We're not going to have this text describing what's going on, but instead we're going to display some fields that are going to be updated. So basically some data. So coming in the info panel, let me go to my scene view so that things are more. Right now I have this info text. It spreads out, so it expands according to the size of the panel, and then it's pushed back by this amount of pixels over here. I'm going to change actually its anchoring to not expand, but to anchor it on the top left corner. So I'm going to hold Shift and Alt and anchor it there. And then I'm going to move it 20 and maybe another 20, sorry, minus 20. Minus 20. Maybe minus 30. And we're going to use this as the title of this panel. So I'm going to rename this so that it makes sense to general info title. And I'm going to change the text to general info. TextMesh Pro gives us some cool opportunities. I can make this text bold just like that. Not general info, let's make it assembly info. Assembly. Okay, I made this bold. Maybe I can change the font size a little bit so that it will pop out from the rest of them. It's 22. And I'm also going to adjust the height. I'm going to take it to 20. Okay, so this is our title. We're going to need 4 more things. We're going to need the overall count, overall weight, dynamic weight, and dynamic count. So we can copy and paste these ones. So Control C, Control V. In here, I'm gonna take it down minus 60, 70. Okay, not bold. Let's take it back to 20 and let's name this overall count or overall count. I'm also going to decrease the width, so let's make it maybe 200. Yeah, that's all right. Overall count, and also change these ones to overall count title. Control C, Control V. We're going to create all of them. So I'm going to move it down. Let's say minus 90, no, minus 100. So this is going to be the spacing. This one was at minus 70. This one is at minus 100. They have a difference of 30. I'm going to remember it for the next ones. I'm going to name this overall weight. Sorry, the title is going to say overall weight. And also name this overall weight title. Overall weight. And similarly, Control C, V. Let's make another one so that we have both. I'm gonna take them over here. Minus 30. So minus 30. This is going to say dynamic count, or maybe, yeah, dynamic count. And I'm gonna change the name here as well. And over here, this one, I'm gonna take it to minus 60 because I already moved the other one to minus 30. And it's going to say dynamic weight. Dynamic weight. Okay, so these are our titles. And maybe we can make the panel just a little smaller. So 180, sorry, not that one. The info panel, 220. Yeah, they fit a little bit better. Okay, and now these are just the titles. We haven't actually created the text components that are going to display the information. So what I'm going to do is I'm going to grab those. Oh, let's change that as well. Dynamic weight. I'm going to grab those, all of them, holding Shift down, and I'm going to Control C, Control V. And I'm going to, remember these are anchored on the top left. If I click here, I'm going to anchor them on the top right, but this time I'm not going to hold down Alt because I don't want them to go over there. I just want their anchor to be considered there. So I'm going to hold Shift only and click here. Nothing is changing, but their anchor has changed. So now you see that when I click on this, this is the anchor. And if I go to X and take it to 0, it's going to stick over there. It's going to take it to -20. And I'm also going to adjust the text to be on this side. And it's going to be empty, so I'm going to do this double dash situation. And I'm going to do the same for all of those. So I'm going to take them to -20 and take their alignment to be on the right side, and then just add the double dash. Did that make sense?
Yeah.
Okay. And I'm just going to quickly change these names to, instead of title, make them say info. Okay, and we're good to go. We're going to go, I'm just going to take this close button over here. And we're going to go to our named im object, which is where we have all these inputs. And we're going to drag and drop the corresponding info text. So the overall count is going to go to the count text. The weight text is going to take the overall weight. The dynamic count is going to take the dynamic count, and the dynamic weight is going to take the dynamic weight. And I'm going to save, file, save, or Control S. Because if Unity crashes, it will not remember the scene information. So the good thing about Unity is that when it crashes, if you've saved the Visual Studio, it doesn't get affected. So most times if the Unity editor crashes, you're not losing your scripts. However, and it crashes a lot, by the way. However, if it crashes, it doesn't save anything on the scene. So when we're doing UI, Control S all the time. Should I move on? Are you all good with this, or should I give it a bit more time?
We're good.
Okay. Okay, so going back to our script then. Let me check. Okay, so we're going to, first of all, write the methods that are going to be responsible for creating this sequential assembly. So we're going to write 3 different methods. The first one is going to be named public void, public because we're going to access it from the slider. So public void update assembly, open, close. Then we're going to create a new one that's going to be named public void text slider order. Or order. This one is going to be responsible to track if we're moving the slider towards the right, or if we're moving it towards the left. Maybe I can name it text slider direction. Makes more sense. Text slider direction. And the last one, we're going to name this public void change object state. So this is going to be the one who is actually responsible for turning the objects on and off. So the first one, so basically we need, we're going to write first this check slider direction. So the first, we need to always be able to keep track of what was the last value that our slider had. So we're going to create over here in the top a private int, which is going to store the last index, or maybe the last value. And we're going to come down to our check slider direction, and we're going to, over here, create a local integer. So int value is going to be equal with the slider. Remember, we gave the slider from the inspector, slider dot value. So this is basically how we can extract the value. It's giving us an error here. So we're extracting the value from the slider. It's giving us an error here. And if we hover over it, it says cannot implicitly convert type float to int. So this is because this is a float and this is an integer. And what we're going to do is we're going to cast this one, to cast an integer to this one. So that means that it's going to create an integer out of this. And we're going to use open close parentheses. And inside here, we're going to use int. So at all times, this rounds it up to whatever integer, this float. And now we have the value. And we're going to create another local variable for this method. We're going to name it float. It's going to be a float. We're going to name it diff. It's going to be the difference from going to this value, from this value to the previous one. So value minus last value. And basically from this difference, we're going to know if it is going towards the right or if it's going towards the left. So if diff is smaller than 0, that means that going to the left, and else if diff larger than 0, going to the right. Okay. We're also going to need over here a private boolean. I'm going to name it increasing, maybe increasing. And this is basically going to hold the information about if it's going to the left or if it's going to the right. So if this is turned to true, that means that our slider is going to the right. If it's turned to false, that means that our slider is going to the left. So I'm going to initialize it as false. Increasing equals false in the start. Basically, whenever we want to initialize data with a starting value, we do it in the start, which is the, if you remember, it's called once when we start playing the game. And over here, we're going to say if it's going to the left, then increasing equals false. If it's going to the right, increasing equals true. Does that make sense?
Yes.
Okay. Before we move on, let's also initialize some more things over here in the start. So we're going to have a private integer. It's going to be the component count. So what else? Yeah, that's it. So over here in our start, let's also count how many components we're giving it. So how many children does this game object have? Remember, over here in Unity, we're in this game object and all of its children are the components. So it's the number of components. So the way to count these is very easy. We're going over here and we're going to say component count equals the transform. transform is the reference to the current component. It's transformed with lowercase t. The transform with uppercase T means the class transform. This is this transform, the one that this game object has. So transform dot child count. So this basically accesses the current game object, and by current I mean the one that this script is attached to, and it's looking for the child count. Control S. And let's print it so that we make sure it worked correctly. So let's do debug.log component count. We can either do it to string or it will convert it to string by itself. Control S, and let's come over here and let's click play. And we see that I have 191 components, which is correct. Starting from 0 all the way to 190 is 191. Okay. I hope it's okay. Okay, so now we have the component count. And we're going to come over here and we're going to write this method, the change object state. And this one is actually going to take some parameters inside. It's going to take an integer, which is going to be the start index. And it's also going to take another integer, which is going to be the num indices. So the start index, it's going to know where to start, either turning objects on or off. And this tells it how many indices you're going to turn on and off. And we're going to run a for loop over here. First of all, this function is going to be called over here. So we're going to call change object state. And this is going to be the last index, sorry, the last value. And the how many indices, it's basically going to be the absolute value of this difference. Remember that this is either negative or positive. We want the absolute of it because we just want the count. And the way of getting the absolute value, we can access the mathf class of Unity. So we're going to type mathf dot absolute, open close parentheses, and inside here we're going to put the diff. And of course, again, it's a float, and it says cannot convert from float to int. So again, I'm going to cast an integer in front of it. So now it is correct. Did this part make sense with the absolute? Okay. So over here in the change object state, basically what we're going to do is we're going to say for how many, we're going to loop through this number of indices, and starting from this one, we're going to either increase, turn them on or turn them off based on if this increasing Boolean is true or false. So first we're going to write our for loop. We're going to say for int I equals 0, I smaller than the num indices, I plus plus. And then we're going to say if increasing equals true, sorry, equals equals. This is how we check equality. If increasing equal true, then what do we want to do? We want to grab the child, the current one. I know its index. It's going to be the starting index plus this I. And I want to grab it and turn it on. So the way to do that is, again, I'm going to access the transform, which is the parent object. And I'm going to go and I'm going to type get child. And I'm going to, over here, it requires the index of the child, as you can see. So I'm going to say the index is the start index plus I. And then from this child, I want to extract the game object. And I'm going to access the method that's called setActive. And I'm going to turn this to true. So this little bit is going to turn this game object on. Did that make sense? How we access the child, we access the game object, and we're setting it to true.
Yes.
Cool. So else means that the Boolean is decreasing. We're going to do something similar. We're going to get this one. I'm going to Control C, Control V, sorry. Control V. But this time I'm not going to be adding the I, I'm going to be subtracting the I. So minus I, and the setActive, I'm going to take this to false. All clear on this one? I hope so. So over here in the update assembly, we're going to write this one now. This one is
Eliana,
yes.
can you just repeat the last part?
This one.
Yes.
Yeah, so if we are decreasing, that means that, let me annotate. That means that we're going this way. So if this is our order of game objects, this is the current one, this is our starting point. We don't want to, we want to take the ones previous from it. So instead of increasing, we're going to decrease. So that's why we're doing minus I, because we want to get, if this is 10, we want to get 9, we want to get 8, we want to get 7. Does that make sense?
Yeah, thank you.
Okay. So this one, the update assembly, is basically responsible for now, because we're going to add some more stuff to it. It's responsible of basically updating what was the last index. So we're going, sorry, what was the last value from the slider. So we're going to need an integer. I'm going to name it value. And is equal to, it's basically the same over here. It extracts the value as well. So I'm just Control C, Control V, extracting the value from the slider. And I'm going to say that the last value equals this value. Okay. And that's it, Control S. Oh yes, one other thing that I forgot is we want to go over here in our start function. Remember how we found what is the component count? We want to make sure that, interesting how I lost my taskbar. Awesome. We want to make sure that we also assign this component count as the maximum value our slider can take. So we're going to come over here. I'm going to say slider dot max value equals component count -1, because as you know from Grasshopper lists, we don't want the length of the, we're not, if we're doing list item, we're not going to use the count of the list to get the last item. We're going to use the count -1, right? I hope so. So Control S. Okay, here. But look at that. Okay. I guess that's how we're going to navigate from one to another. Okay, so coming over here, we want to, in our initial state, we want all of these game objects to be turned off because we're going to turn them on and off from the slider. And in the beginning, our slider is set to 0. So that means that all of these components are turned off. So I'm going to grab the first one, click on it, hold shift down and click on the last one. And then over here in the inspector, I'm going to unclick this check mark, which basically turns the component on and off. So now these are all off. Okay. And we want to come over here to our slider, and we want to add some stuff. We want to add basically the two events. So the first one we're going to add is, we're going to bring this over here, the name, because this holds the script. We're going to go to the assembly manager script, and from this one, we're going to add check slider direction. So this is the first one that's going to be executed. And then coming over here, again, named. And we're going to go to the assembly manager, and we're going to do update assembly. I'm going to save, and I'm going to let me make sure that I have initialized the last value as 0, because I'm not sure I have. So we have here the last value. Yes, let's also make sure that we set this to 0. So in our start, increasing equals false, let's say last value equals 0. Because otherwise, I'm not sure what it's going to do when we do these subtractions if it doesn't have an initialized value. So Control S, back to Unity, and ready to play this. So I'm going to click on play. Nothing is happening. And then slowly I can see them turning on, turning off. Okay. Is that part clear?
Yes. Yes.
Okay. So we did the sequenced animation. What we haven't done is assign the colors based on this gradient that we gave over here. So to do that, we're going to go back to our script. This is painful. We're going to create a new method, and let's see how I named it. Oh yes, okay. So let's take it under these ones, and I'm going to name it public void color by index. And this is basically going to take inside an integer parameter. It is going to be the size of the collection at the current time. And basically what we want to do is, let me take you back to the slider so that I can explain this better. Sorry, to the gradient. So remember that we had this gradient, and basically we want to color according to the number of how many indices are open and which index is which, how many components are open, sorry, and what is the index of the component in the list. So we're going to use a method that's called, basically the gradient class has got a method that's called evaluate. And what it requires is a number from 0 to 1, a floating number from 0 to 1, which is going to give, oh, it went away. Anyway, I'll show it here. It's going to give a color that's ranging this range, and this is 0 and this is 1. So according to which number we're going to give it, it's going to evaluate this gradient in this color, and it's going to give us back the corresponding color. Does that make sense?
Yes.
Cool. So back to the script then. Basically what we want to do is we want to make sure, based on the size of the array, remember when we're turning the slider on and off, we're readjusting the number of on items. So this size is constantly going to be changing. And we want to, in the current size, for each component, give it this T number that it's going, so that it's going to get the corresponding color. So we're going to write a for loop for as long as this size. For int I equals 0, I smaller than the size I++. And then we're going to create this t number. So we're going to say float t equals. Now, how can we get a number from 0 to 1 when we know the size of the collection based on the index? I think we've done this before, but anyway. So we're going to basically divide the I with the size -1. I'm going to put this in the parentheses because the division is going to be executed first if I don't. So it's going to do I divided by size -1. And because this is an integer, this is an integer, when it does this division, it's going to give me an integer. Unfortunately, I'm just going to multiply this by a float so that it makes it a float. So 1.0f. And now I'm sure that this is going to give me a floating point number. So this is my t, my parameter t. And then to extract the color from the gradient, I'm going to use a color call equals, how do we name it? Sequence color dot evaluate at t. Did this part make sense?
No, can you explain it again? Sorry.
This one?
Yeah, the 2 lines. Yeah.
Okay. So the first one is basically trying to get a number from 0 to 1. It's like resizing let's say we have a list of items that we have 10 items. So we have item 0, 1, 2, actually this 11 items, 3, 4, 5, and so on, so forth. And we want to resize this to go from 0 to 1. Now, because we don't want to remap it, we don't want to remap it to something custom, we want it to be from 0 to 1. Basically, if I take the index and divide it by the overall number of items that we have, -1, so this one, I'm going to get this number, because if my index is 10, then this is the one that's going to give me 1. If it is 9, it means 9 divided by 10 is going to give me something smaller than 1. And then it's going to be 8 divided by 10, something more smaller than 1, etc. And 0 divided by 10 is going to give me 0. So what I'm going to get is a range of numbers that this is 0, this is 0.5, and this is 1. Did that make sense?
Yes, thank you.
And then the other thing that we did, just because the division of I divided with the size -1, because this is an integer and this is an integer, their division is going to give us an integer. That means that, for example, if I do 1 divided by 10, which would normally give me 0.1, because this is trying to output an integer, it's actually going to make this into 0, and we don't want that. Okay, so that's why we multiply the I with this 1.0f, which is a floating number. We're not changing its value, we're just sneakily turning this into a float, so that this division is going to give us a float. Does that make sense?
Yes.
And this part is what I explained before. We're basically evaluating the range of color. So this is our gradient. You know, our color, it goes from 0 to 1. So when we evaluate with this t, remember this t is corresponding to the item in our list, so to a component. And we're going to say for component 0, give me evaluate at 0, so give me this color. For component equals size, so in our previous example, for component 10, give me this color, give me 1. For the half of it, give me this color. And this is how we're going to color our components. Okay?
Yes, okay.
Cool. So we extracted the color. We haven't actually colored the component. Let's do that. The ESR component. So again, to color it, we need to access the game object. So we're going to go to transform.getChild. We're going to get child I. And then from this child, we're going to get component. Remember which component is responsible for rendering elements. It's the mesh renderer, and this is the one that holds the material for the game object. So we're going to grab the mesh renderer, open close parenthesis. This is how we grab the components basically. We say which component, open close parenthesis, because this is a method. And then from the mesh renderer, we want to extract the material. And from the material, we want to extract the color. And we set it equal to this call. Did that make sense?
Yes.
Okay, so over here, we created this method. Now we have to call it. So we're gonna call it over here in the update assembly. And we're going to say basically that color by index and the color by index. Yes, and the current count is equal to the value. Control S to save it. And let's go back to Unity. And now if we play this, we should be coloring them correctly. You see how the last one is turns red? So of course, as the range grows bigger, this fits more components. So it's not just one red anymore. Yeah. So this is the coloring. Obviously, you can change the slider to whatever. Let's save it. No, it can be have a larger range, actually. Don't I have any good ones here? It can have a big range. It's not going to be so obvious what is which. But you see, based on their order in the list, they get the colors of the slider, of the gradient. That all makes sense?
Yes. It did.
Puyan, are you the designated yes sayer?
I'm trying to save the time for the class.
I'll take it. Okay, so what else? Oh yes, we haven't done two things. The first is to update the values, and the second thing is to animate the slider with a button and not with the hand necessarily. So let's first maybe update the UI values that we have in the information panel. So we're going to do two separate methods. We're going to first have a public void update constant UI. And we're going to have a second one, public void update dynamic UI. So goes without saying, this is where we're going to update the count of element, the overall count and the overall weight, which they're not going to change as we move the slider. And this is going to be called every time we're moving the slider. So we're updating how many elements. So the dynamic weight and the dynamic count are updated. So this one, what we're going to need, or basically what we're going to say is, remember we had the count text and the weight text. So we're going to say count text dot text. Remember what this does is it goes over here. This is a count text. So it grabs this game object and then it references this one, basically the text input. So context dot text equals the component count to string, because this takes a string element to string, and that's it. And the count weight, is this how I named it? Weight text, yes. Dot text to access the text element is equal to component count times the component weight. Let's take this into a parenthesis so that it knows that it's one thing, and we're going to make this to string as well. So, and I'm going to call this in the start. Oh, great. Sorry, these ones are for the constant UI. So I'm going to place them over here. Sorry about that, in the constant UI, because these are not changing. So I'm going to call this method in the start, right after we have configured what is the component count. So over here, we're going to say update constant UI. Control S to save it, and let's see what it gives us. So when I play, it comes over here, and you see overall count and overall weight of our components. Back to our dynamic ones now. Oh yes, sorry. Let's give also a parameter, integer parameter into this one. Let's have it be the size. So basically we know how many components we currently have, and we're going to say that our dynamic count text dot text equals with the size to string plus open close quotation mark. I'm going to use the slash plus the component count to string. So this is basically going to give me one number slash the overall number. And similarly for the weights, I can do d weight text equals the size multiplied by the component weight. Put them into parentheses. To string plus, sorry, this is that, plus slash plus the component count times, sorry, not component count. Oh yes, you're right. Component count times component weight dot to string. Give me a moment. Yes. Okay. The other thing, so let's do that, Control S, and let's go back. Oh yes, we want to call this method, and we're going to call it where we called the color by index. So basically we want to say update dynamic UI, and the size is the value of a slider basically. So file save, sorry, this one, and back to Unity. And now if I play, let me make this large. You see that as I keep adding components, the dynamic count is updating, dynamic weight is updating. Okay. Is that good for everyone?
Yes.
Cool. The last thing that we're going to do for today is we're going to basically animate the slider by using a button. So we want to, when we click this play button, to start playing the slider, start creating the sequence of the assembly sequence, start building it, and when we stop, to stop it, and then we're going to have the manual control as well. So this is going to be actually quite simple. So we're going to create over here another Boolean, private bool, and I'm going to name this animate. Animate is going to be initialized as false, same as increasing was. So animate equals false. And then we're going to write two very simple functions. One is going to be called public void animate. I'm going to name this animate slider. And it's going to take a Boolean parameter, which is going to be, I'm going to name this start. And basically what this is going to do is it's going to assign this Boolean to the animate variable. And this is going to be something that's going to go outside into the stop and play button. And basically from these two buttons, as we did yesterday, we're going to pass a Boolean inside our script. And we want a second method, which is going to be responsible for actually changing with a script the slider's value. So we're going to write public animate slider value. And what this is going to do is basically going to say that if the slider dot value has not reached its final value, which I know what it is equal to component count minus 1. This is the last it's going to take. Why is this red? Oh, sorry, I forgot the void. My bad. Public void animate slider value. So if this has not, sorry, it's smaller, not equal. If it has not yet reached its final value, then what we're going to do is we're going to add to the slider value the step that we set up before. Remember, we had this sequence step. So this is going to be a number that's going to be added over here. So we're going to do plus equals slider step. How did I name this? Sequence step. Sequence step. And basically all that we need to do is we need to call this method in our update method if this Boolean is true. So we're going to come into our update and we're going to say if animate equals true is equal to true, then animate slider value. Did that make sense?
Yes.
Okay, so over here in Unity, all we have to do is go to this play button and we're going to drag this over here and we're going to say animate. This is the play, so this is checked. And in our stop button, We're going to drag this one and we're going to say again, animate slider. No, don't animate. So let's see what happens. If we click, oh, I think I forgot. Do I have a step number? Okay, I do. So then I was all good. So if I click play, this starts animating. If I stop it, it should stop. And then when it's stopped, I can manually do it. Again, if I click play, it's gonna keep going. Stop, do it by hand, whatever. And remember, this works as yesterday, and this should work as well. Yeah. All good?
Yes.
Okay. Of course, you can give a lot more information over here about your assembly. You can even bring some information from Grasshopper as CSV. I don't know what is interesting for your specific, project. I just added some generic things over here. Yeah. Any questions?
I have a suggestion regarding the steps.
Yeah.
So right now the step is 0.1, right?
Mm-hmm.
So maybe it can be like a division of the number of components divided by the number of components, and then this would result in the step, and then the step will be related to the number of components. So at each step, you will definitely get one component.
Yes, but we could have just increased by 1 then, instead of doing that. But because this is executed in the update function over here, the update function is executed many times. So if we had 1, it's actually going quite fast. That's why I added this smaller step. So we will see it. Let me change the step to 1 so that you see what I mean.
It wouldn't be so visible like in this.
Look at that. Look how fast it goes.
Yeah.
This is basically doing one component in every step, in every frame. So this is how fast it goes. I added this. Yeah, it's not stopped. I added this one so that it wouldn't go this fast, and you would have some control over the speed. Did it make sense, or were you talking about something else?
I think so. Yes.
Okay. Anything else?
I have a question regarding previous session.
Yes.
So I was trying to change the size of the canvas, and when I clicked on it, it was like it's unavailable to change it.
Yeah, I think that is because you can add this though. This is basically where we change the size from over here. You need to have it to scale with screen size, and then you can adjust it from over here. Otherwise, I think it tries to adjust to your camera because we have a screen space overlay. So
I think this works, yeah. Yeah, thank you.
No problem. Any other questions? No? I guess no.
Ileana, can you go back to the script towards the end part, please?
Yes. over here.
Yes.
Ileana, I had a question regarding the big geometry. So when you exported the geometry, each component was in a different layer?
No, it wasn't. Let me go there. I think I have it open. So it's this one over here, and I named them. I'm not sure if this made a difference. Let me see if it does. So okay, let's say that these are unnamed. So I'm just gonna bake them. Okay. And then I'm going to grab those and file export selected into an FBX, and I'm gonna name this whatever, test FBX, save. Also make sure you have this map Rhino Z to FBXY. This is taking care of the conversion, that because Unity has Y facing upwards, the Y coordinate. So I'll click OK. And then over here, I think it's here. Yes, let's bring it inside, see what happens. Yeah, you see, it has them as separate objects over here. So you don't need to do anything. They don't need to be in different layers. They just need to be different objects, and they're not joined, they're not welded, nothing. And also export as FBX because OBJ, for some reason, joins them in one whole, in one mess.
Got it. Thanks.
No problem. Any other thing? Anything else? So, was there a question? No, it was Milad. I just heard the mic opening.
That was me now.
Yeah, I wanted to say that if you want to bring things inside from your Wallace optimization process, it's quite similar to what we did just now. So I'm not going to go through it tomorrow because it's a very similar process. Basically, you're going to have a list of game objects, going to be your list of phenotypes, and you can animate them in the ways that we showed today. So because we have one more day, I'm going to focus on the last bit, which is going to be giving some general information about your thing. We're going to import some videos and display some other things for tomorrow. But if you get to it, if you want to bring inside some Karamba stuff, or if you want to bring inside some Wallace stuff, and you get into trouble, email me and we can either set up a Zoom or, all right, I'm just going to email you back if it's something simple.